Here, this class is a follow-up to the previous episodes on addition and subtraction of algebraic fractions. So I'm going to solve further problems on this subject. Example, we're asked to simplify this. So the first thing we do is to factorize our left-hand denominator to see if it contains linear factors of the right-hand denominator. And of course, even if it doesn't, it will make the solution to be easier. All right, so when we factorize this quadratic expression here, what we are going to have is now x minus 2 all over x plus 3 bracket x plus 2, okay? Then minus 5 all over x plus 3. All right, so this is our next step. And of course, you now see that our right-hand fraction contains linear factor of our left-hand fraction. Okay, so the next thing we do, we go ahead and make the denominator to be uniform by multiplying this right-hand fraction, all right, by x plus 2 over x plus 2, the principle of up and down, all right, x minus 2 divided by x plus 3, okay, x plus 2, which nothing changed, minus 5, okay, divided by x plus 3, which was originally there, then by modified one, which is x plus 2, okay, all over x plus 2. All right, so notice the inclusion of x plus 2 over x plus 2. And of course, we know that x plus 2 divided by x plus 2 is equals to 1. So what I have just done is I multiplied this particular fraction now by 1 in the form of x plus 2 over x plus 2. And this is to unify the left-hand fraction and the right-hand fraction so that they can have a common denominator, thereby making the fraction easier to solve. All right, so since the denominators are the same now, all right, what we have, of course, we now have x minus 2, the numerator, then of course we expand here, minus 5 times s will give us minus 5x, all right, and minus 5 again times plus 2 will give us minus 10, all right, so please endeavor to make sure that you are expanding correctly, because students normally make mistake around this point when they expand with minus sign. They use the minus only once for the first time and they forget other terms that are inside. So let your minus affect everything, because here the minus is minusing the entire fraction. All right, so you should affect everything when you are expanding. All over your denominator now, x plus 3, all right, bracket x plus 2, since they are not the same. Okay, now you collect your like terms and you will have, okay, x minus will give us minus 4x, all right, minus 12, okay, minus 12 over your common denominator, x plus 3, bracket x plus 2, all right. So we don't stop here, we'll still check whether we can factorize this, and of course we can factorize this further. And if we factorize this one, will it have anything common with the denominator? But we'll factorize out, we'll have minus 4, which is common, into x plus 3, okay, divided by x plus 3, all right, bracket x plus 2. And of course, we can see something common now, all right, linear factor x plus 3 is common, we cancel linear factor x plus 3. And of course, what we are now left with is minus 4 over x plus 2. So we now have our final answer is minus 4 over x plus 2. And at this point, we stop because we can no longer go further. All right, so that is the solution to this particular example. All right, so I take the next example, which is 2 divided by x minus 5, okay, plus x minus 23 divided by x squared minus x minus 20. All right, so in this example, once again, following similar process, you will discover 2 all over x minus 5 plus x minus 23 over, when we factorize this our quadratic expression here, what do we have? When we factorize that, we are going to have x minus 5 bracket x plus 4. This is what we have by factorizing that quadratic expression. All right, so after factorizing, what you notice, you discover that this is a linear factor of this other one. So this fraction needs to be unified so that it contains similar denominator as this other fraction. So multiply your left-hand fraction by modify 1, which will contain x plus 4 over x plus 4. Since our left-hand fraction doesn't contain x plus 4 over x plus 4. All right, so we have 2 all over x minus 5, originally there. Then you can now see that I'm going to include x plus 4, okay, over x plus 4. And of course, x plus 4 over x plus 4 will still give us 1. So it will appear as if the fraction is unchanged. Then plus what was originally here at the right-hand fraction, okay, which is x minus 5 bracket x plus 4. All right, so now the denominators are unified. What do we do next? The next thing we do now is to solve the numerator accordingly. You expand 2 times s will now give us 2x, okay, plus 8. When you expand that, then plus x for this other fraction, then minus 23, all over a common denominator, x minus 5, bracket x plus 4. Okay, so this is what we do. When you simplify your numerator further, what do you have? After simplifying further, you discover that this will give us 3x, of course, minus 15 in our numerator, all over x minus 5, bracket x plus 4. Okay, are we done? We need to check whether our numerator can be simplified further and is factorizable. So we have 3 into x minus 5 divided by x minus 5 and x plus 4. Okay, now we see that our denominator and our numerator have similar linear factors. So the next thing is to cancel out the principle of interaction. Expression, we cancel expression, similar expression. So x minus 5, we cancel x minus 5. And of course, we end up having 3 all over x plus 4 as our final answer. All right, so you notice that in your denominator of your right-hand fraction, that it is a linear factor of your left-hand side raised to the power 2. So this same thing is written as 2x over x plus 1, all right, plus 3 all over x plus 1, all right, multiplied by x plus 1. Because this is s squared, s plus 1 all squared, so it appears twice. So s plus 1 multiplied by s plus 1. And of course, you can still follow the same principle of unifying the denominators by having it as 2x, okay, over x plus 1, originally there, then multiplying by a modified one, which is x plus 1, okay, over x plus 1 here, so that the denominator of the two fractions can be the same. Then 3 all over x plus 1 bracket x plus 1. I can now see that the denominators have been unified. So what is the next thing to do? After you have unified your denominator, the next thing is just to solve the mass normally by expanding out your numerator. So we have 2x times this will give us 2x squared plus 2x plus 3 over x plus 1 bracket x plus 1. All right, so what do you do next? Do you stop here? Of course, you don't assume that you are done with that solution. So what you will do now is to factorize your numerator. And how do you factorize that? Of course, 2 times 3 will give us 6. Factors of 6 that we use to factorize 2 to replace 2. Is it possible? to get a factor of 6 that you can use to do that, of course, is not possible, because when you consider 6 and 1, okay, you have 6, and 6 plus 1 is 7, 3 and 2, so nothing can go, and 6 nothing can go. This is where you stop for this answer, because your numerator is not factorizable, all right? But in this case, our denominators are just real numbers, all right, instead of algebraic numbers. So we write it in a clear form as x minus, okay, 3 minus x all over 2, okay, plus 3 times the bracket will give us 3 into the bracket, 3 plus x, all right, all over 4. Okay, this is over 1. And of course, you can see we can also unify the entire fraction denominators. How do we do that? This particular one don't have 2 and don't have 4. So we can multiply this, our first fraction, by 2 and 4 by saying the same thing as having x, okay, over 1 originally there, and of course inserting modified, I'm going to have 2, I'm going to have 4, okay, multiplied by 2 and also 4. They are the minus, okay, this other fraction, minus 3 minus x, okay, originally there, over 2. Now, what does that fraction have? It doesn't have 4 and it doesn't have 1. So multiply by 4, okay, multiply by 1, and I will insert, okay, 4 and 1 under also, then plus, all right. Then the next fraction that was originally there was 3 into 3 plus x, all right, divided by 4. And what does it have? It doesn't have 2 and 1. Of course, multiply by 2, multiply by 1 over 2 and over 1. And in this case, once again, you can discover that we have unified the entire fraction. So we just go ahead once again and solve for the numerator and simplify everything that we need. So we're now going to have our entire fraction as, when you expand, 2 times 4 is 8 times x. We have 8x, all right, okay, minus 4 times 1 is 4. So times this minus is here, you're going to have minus 4. So if you use minus 4 to expand, you're going to have minus 12, okay, and plus 4x, all right. Thank God we have positive numbers in our numerator here. So 2 times 1 is 2, times this outside is 6. So using 6 to expand this fraction, you're going to have plus 18, all right, then plus 6x. That is our entire numerator. Then, of course, our common denominator, which is 2 times 4 times 1, to give us 8. So we have 8 in our denominator. Simplify your numerator now. 8x plus this will give us 12x plus this. We have 18x. So we have 18x. And our numbers will have plus 6, okay, all over 8. And of course, when you factorize your numerator, so that you can have a factor, the principle of interaction. Remember, expression, we cancel expression, and terms, we cancel a term. Okay, so when you factorize to bring out the factor that we do, you can bring out 2 outside to interact with the 8 that is a term there. Since the numerator is an expression, you don't go and say 2 go here 4, 2 go here 3, and you leave this one like that. That should be wrong. All right, so you factorize and you have, okay, 9x plus 3 here, all divided by 8. And of course, when you now cancel that, this 2 will go in this 8, you'll have 4. All right, so our final answer will now give us 9x plus 3 divided by 4. Okay, or you can factorize the numerator as 3 into 3x plus 1 over 4 as the final answer. All right, so thank you very much for watching. All right, so but before you go, I'm going to give you some work to do as a form of classwork or homework for you. All right, so I'm going to give you the answer. All right, so you can pause your video, and of course, for me to write the answer. The answer for this other one, when you first for this other one, I will purposely not give you the answer. Of course, if you are comfortable solving 1, 2, and 3, of course, then it means that you actually learned, all right, this subject matter. Thank you very much once again for watching. All right, don't forget to like this video and also hit the subscription button And of course, watch out for multiplication and division of fractions. I hope you enjoyed this class. Good luck. Thank you for watching.